Hi folks, we're going to take a look at number 9a from page 139. So what they're asking us to find is the equation of the tangent to this function here at the point 0.5, negative 1. Okay, now this is a little different from most of the questions we've been answering because they're looking for the equation of a tangent. Now remember that the tangent is a line. So in the end, what we're looking for here is the equation of a line that's tangent to this curve. Okay, so what we need is we need a point on the line, which we have, because if it's tangent to this curve at 0.5, negative 1, we know that the tangent shares that point with the curve. So we have a point on the line. Next thing we need is the slope of that tangent. But we know the slope of the tangent is just given by the derivative of this function at that point. In other words, the rate of change. Okay, so our first order of business is to try to find the rate of change of this function at x equals 0.5. Okay, so what we're going to be looking for is the derivative of our function y, okay, with respect to x. So here I'll use the Leibniz notation just so that we start getting used to it. So the derivative of 2x, well again, 2 is just a constant. So I just multiply that by the derivative of x, which we know is equal to 1. Eventually, I'll stop being so explicit. Okay, we should be able to look at this and know that the derivative is equal to 2. Okay, then minus, now remember here, 1 over x can be thought of as x to the negative 1. So that's what I'm taking the derivative of. So x to the negative 1. So our exponent becomes our coefficient, and then the exponent goes down by 1. So negative 1 minus 1, negative 2. Okay, so you'll see as I do more of these questions, I'm going to put less and less detail. So here, what do we have? We have 2 plus, and this just becomes 1 over x squared. Okay, but we want the derivative of this function at x equals 0.5. Okay, so the way I'm going to write this here, if I'm using this Leibniz notation, so this represents the derivative function, and I use this line here to represent which x value I'm evaluating it at. Okay, so instead of using the bracket like we would with our functional notation, okay, this is how I'm going to identify the derivative of this function with respect to x evaluated at 0.5. Okay, so here all we have to do is plug in 0.5 for x, and we're left with 2 plus 1 over 0.25, and here this is like a quarter, so 1 divided by a quarter is the same as 1 times 4 over 1, so 2 plus 4. So the slope of our tangent is equal to 6, and I'll keep this here. This is the point on the line, so let's stick everything into y equals mx plus b. And we've got y is negative 1, our slope is 6, our x value is 0.5. Okay, so negative 1 equals 3 plus b. So b is equal to negative 1 minus 3 is negative 4. Okay, so the slope of our tangent is equal to y equals 6x. Remember, 6 is the rate of change at that point, and then minus 4. Okay, so just to recap here, since we're looking for the equation of the tangent, we know we're looking for the equation of a line, and we need a point and a slope. The point is given because it's shared with the function at that x value, and the slope is determined by finding the derivative of our function at that x value. Okay, that's it.